Hey guys. All right. So today we're going to be doing lesson 5 in the chapter. And so this in your workbook is on pages 553 and 554. The page that I'm on is page 553. We're just going to talk about it really super briefly. Not even going to write anything down, but we are going to go through starting on page 554. Okay, so we're going to be doing similar triangles again. So basically setting up those ratios, those proportions, and then finding some really cool things. So I want you to actually take a look at this picture down here. This is what we're going to be kind of doing. So when it says indirect measurement, you can basically use information that you know and information that is easy to access to find out information about things that are not so easy to access, like how tall one of the Great Pyramids are. Okay, so that's what we're going to be doing. This is what it means when it says indirect measurement. So we're going to be talking about how tall you are versus how tall, like, something else is. Okay, the Statue of Liberty or the height of the Great Pyramid. Okay, all right. So let's go to the next page, page 554, and let's take a look at what it says. All right. So the first thing it says is angle similarity. What in the world is that? Angle. So it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Remember, they're not congruent. The triangles aren't congruent because for congruent triangles or congruent figures, you have to have the same angles and the same side lengths, right? The lengths of each side have to be the same. And that's not what this is saying. This is just saying you have the same angles, but not the same side lengths, okay? So it's not congruent, it's definitely similar, but I'm a little concerned about this two angles thing. So if two angles of one are congruent to two angles of another, then they're similar. Well, why? Why only two angles? Aren't there three in a triangle? So why are we only talking about two? So I definitely want you to be thinking about this as we kind of go through the next couple of problems, okay? We're going to actually take a look at example number 1, and there's a couple of really cool things that we're going to do, okay? So the first thing we're going to do is we're going to decide, hey, are these triangles similar? Do they in fact have this AA similarity, right? Are two angles actually similar? So if you take a look at this picture, you can see, hey, here's one, 62 and 62, but 48 and 70, those are not the same angles, okay? And so if you look over in the description, they say, 108, 180. What do you know about 180, right? You know there's 180 degrees inside that triangle. And so you can find the missing pieces. So if we take 180 and we subtract 62, right? Then we know that one of our angles is 48 and we can get the other angle to be 70. Okay? Okay, so sorry about that. We had a pickle problem. So I don't remember where I was, but basically, this is so fun, guys. So basically, two of our angles, right, are the same. And so we know that these two triangles are similar, okay? The only other thing that we're going to have to do with this particular problem is we have to write this similarity statement. So I don't know if you remember from a couple of days ago, the little video I showed you what the similar symbol is, right? And it's just that tilde sign, right? So remember, this means congruent. Just the one symbol means similar. Okay? All right, so let's go do the got it at the bottom of the page. Got it? Let's go get it. All right, so far with our two triangles, we know that we've got 110 and 110. So we have one angle that's the same, but do we have two? Okay, I wish I could hear your point or hear your voices and give you guys bonus points if you can name those two angles. I just put a dot on. They're special angles. But these two angles, whatever they are definitely the same. Can you name those angles? Vertical angles. They're vertical angles, and we know that they're the same. So I don't know who gets the bonus because this is a recorded video. So Sorry about your luck. Okay, so definitely going to be similar. Now we just have to figure out what is similar, right? And let's go get the letters in the right order, okay? So, yes, they are similar. And let's go get those triangles. So, triangle. Let's go HJK. And it's similar to, so which one do I write first? Here's H, and I got to go to J. Right? So I know I'm starting, because I'm starting with that 110 angle. So I know I'm starting at L, and then I'm going to go to M. So L, M, and then into K. Okay, so H, J, K is similar to triangle L, M, K. All right, let's go do this indirect measurement thing on the next page. So if you take a look at these examples, what in the world is happening right now? What is going on? Okay, so the paragraph up at the top of the page is and you can totally read it, but what I want you to think about or understand is this idea of shadow reckoning. Okay, sounds really weird and sounds kind of like I don't know, phony baloney, but it's not. Okay. Basically, what's happening and what we can do is at the exact same time, right? When the sun is shining, you or some object is going to cast a shadow on the ground. Okay. And you can basically measure this shadow at the same time, measure the shadow of another object. And you can use this idea of similar triangles, right? Because the shadow, the sun ray is casting the same angle, and you can find the height of some really large objects. Okay, and so let's go take a look at example number 2 and see what's happening to kind of get an idea. Okay, so there's this little itty bitty fire hydrant that is 2.5 feet tall, and it's got a 5-foot shadow. Okay, and then there's a lamp post that is measured to have a 26-foot shadow. And again, the sun is shining at the same time. So these angles up here are the same from the sun rays, okay? And so basically we can use a proportion or a ratio in similar figures and figure out how tall the light post is, okay? And so that's what we do. Let's go take a look down here at example number 3, okay? So same idea, okay, except that we are going to cross a lake. So this blue blob over here is a lake, okay? And we somehow know these distances. Now, I don't know how we know these distances, but we do, okay? And so I know, and we can use this little triangle right here with the sides 40 and 320. And then we can use the bigger triangle that has this distance across the lake that we don't know. And then this distance over here, this is probably about as hairy as these problems are going to get. If this part is 320 and this part is 162, then the whole side of that triangle is going to be 482. Okay, and so that's why when you look over here at the triangle or the proportion, excuse me, that they set up, you can see they used a 40 and a 320, right? Came from the same one. And then they used a 320 and a 482 because this piece and the whole thing represent the same piece. Okay, let's go try the got it on the other side. We'll try an example, but again, you are just setting up proportions and they should be pretty easy, okay? All right, so get it? Let's go get it. At the same time, a 2-meter street sign casts a 3-meter shadow. A nearby telephone pole casts a 12.3-meter shadow. So how tall is the telephone pole? So you can draw a picture if you want. Here's a 2-meter sign and a 3-meter shadow. Here is a telephone pole that I don't know how tall it is, but I do know that my shadow is 12.3. Be careful. Make sure you put your shadows on the ground. Okay. And so you can set up your proportion and it's going to look just like that. So 2 over 3 is going to equal x over 12.3. Okay. Let me get my handy dandy calculator. Turn this puppy on. So I know that 3x is going to equal 12.3 times 2 is 24.6. And when I divide by 3, I get 8.2. And so it looks like my telephone pole is 8.2 meters tall. Okay? So at this point, I want you to go pause your video and you're going to do the guided practice. When you get done with the guided practice, you're going to unpause your video and check your answers. All right, so I'm hoping at this time you are ready to check your guided practice answers. And so let's take a look. Number 1, did you get a yes? And did you make sure that you put your letters in the correct order? Okay. Number 2, they are not similar because when you do 180 minus 35, I did the big triangle first, you end up with a 55. And so we're looking for a 35 and a 55. And so this isn't going to be a 35 and a 55. Okay. So no, they're definitely not similar. And then how tall is the tree, right? And so you're just setting up a proportion. So here's my dog, I guess. I don't know. That's a dog or a kangaroo. And there's a shadow. Here's the height of the tree and its shadow. And when you do a little bit of cross multiplying, you should get 3.3. And then over here, right, 4 and 8 go together, 4 and 5 go together, set up a proportion, and you get a 10. Okay, so hopefully you're doing okay and you're ready to move on. So when you're ready to move on, here's what you're gonna do. Okay, so starting with page 557, I want you to go through and go try all of these problems. Okay, set up the proportions for them. You're going to look at you getting to skip all kinds of good stuff. So you can skip this page again, right? All those hot problems you can skip. And then I want you to work on page 559. There's just a couple of more. And then just a little bit of review, page 560. Okay? Oh, someone's at the door. I think that might be the trash man. The trash are still working. The trash guys are still working, which is great because we've got a lot of trash in here. We've got an empty toilet paper roll, as a matter of fact. Isn't that funny? All right, so your homework is page 557. Okay, you can skip page 558, page 559, and then page 560. All right, toodaloo. See you later.